This video is going to be quick instructional on how to multiply and divide scientific notation. To know what scientific notation is, you should look back at previous videos. We're going to use nothing more than a four-function calculator. First problem we have here is 6 times 10 to the 8th being multiplied by 5 times 10 to the negative 2 power. First thing you're going to do is multiply the a values out in front, keeping in mind that scientific notation is always written in the form of a times 10 to the nth power, where a is some number greater than or equal to 1 and at the same time less than 10. So 6 times 5 gives us 30, and we shouldn't have to use a calculator for that. And then we bring down our times 10, and then we're going to do our powers of 10, which is going to be 10 to the 8th times 10 to the negative 2. Now the instructions there, according to our previous power properties of multiplication, are to add the exponents. So it's going to be 10 to the 8 plus negative 2 power, and that ends up giving us 30 times 10 to the 6th power. And right now this is not proper scientific notation because the decimal point is here. And we said over here that the a value, which is our 30, needs to be less than 10 but greater than or equal to 1. So what we're going to do is we're going to move that decimal back one place and call it 3. And if you want, you can call it 3.0. It's not necessary to do that. Times 10. But we moved our decimal one place to the left. And our rules say whenever we move our decimal to the left, we're going to add to our exponent. So since I moved it one place to the left, I'm going to add 1. And that ends up giving us 6 plus 1, which would be 7th power. So 6 times 10 to the 8th multiplied by 5 times 10 to the negative 2 ends up in 3, or 3.0 times 10 to the 7th power. Okay, now we're going to try a division problem. And we have 4.5 times 10 to the negative 5th over 9 times 10 to the negative 2 power. So the first thing I'm going to do is use our calculator to actually divide 4.5 by 9. And that ends up giving us 0.5. I'm going to go ahead and put my times 10. But we're dividing. So when we divide powers with like bases, we subtract the exponents. So this is going to be 10 to the negative 5 minus negative 2. Well, keep in mind, minus a negative is really adding a positive. So it's really 10 to the negative 5 plus 2, which end up giving us negative 3. So our answer will have a negative 3 exponent on it. Now this, of course, is still not in scientific notation because this value right here is actually smaller than 1. So what we need to do is move the decimal back one place, and that will end up giving us 5, or if you choose 5.0, times 10. Now we ended up moving the decimal to the right. And the rules say when we move to the right, we will subtract from the exponent. So up here we're going to subtract however many places we moved. We moved one place. And we have negative 3 minus 1, which gives us negative 4. So our final answer would be 5, or 5.0 times 10 to the negative 4th power. Our next example, this involves scientific notation raised to an exponent. Now this will include our multiplication, division, power raised to a power property. Now what we have is inside of scientific notation of 2 times 10 to the negative 5th power, and the whole thing is going to be raised to the 5th power, which means I want to show this number inside times itself 5 different times. The shortcut to that is to distribute our exponent to both of our numbers here. Now keep in mind that there is a exponent of 1 there. So what I end up getting is 2 to the 5th power times 10 to the negative 5 raised to the 5th power. So I've distributed that power 5 on both of them. Remember, there's a 1 here. And a power raised to a power, that rule says to multiply the exponent. So the first one is 2 to the 1st raised to the 5th, or 2 to the 1 times 5, which gives us just 2 to the 5th power. Bring down my times. And over here we're going to have 10 to the negative 5 times 5, which is going to give us 10 to the negative 25th power. Now at this point it looks like we're done. However, our a value over here can be calculated a little bit further. If you know what 2 to the 5th power is, go ahead and write that down. If not, just pick up your calculator and do it 5 times. So it's not 2 times 5, it's 2 times 2 times 2 times 2 times 2, and that ends up giving us 32. So we're going to write down 32 times 10 to the negative 25th power. The only problem with this answer is that it's not in proper scientific notation, because right now our decimal is here and it needs to be over here so that my a value is smaller than 10 and bigger than or equal to 1 at the same time. So I'm going to rewrite that as 3.2 times 10. Now we moved it to the left and we only moved it one place. So what we're going to do to our exponent on our power 10 is add. That rule says anytime you move decimal left, you're going to add to your power 10. So we're going to add 1 because I only moved it one place. If you don't know how to do negative 25 plus 1, please use a calculator. Negative 25 plus 1 is negative 24. And this ends up being the final solution, 3.2 times 10 to the negative 24th power. So scientific notation times other scientific notation and scientific notation divided by, and now we also have scientific notation raised to a power. Our last one's going to be a word problem. And we have an example we actually took from one of the practice problems or practice sheets. This one says Oregon has an area of 2.52 times 10 to the 5th square kilometers. In 2000, the population of Oregon was 3.42 times 10 to the 6th people. The question they're asking is how many people were there per square kilometer in Oregon? So the question is the important thing. They're asking how many people were there per, and this is an important word, square kilometer. They gave us information about people here, and they gave us information about square kilometers there. The question is, what does this per mean? Per can be multiply or divide. In this case, they're asking a population density question, so it's going to be a division. The question is, how do we divide it? Do we do kilometers, square kilometers divided by number of people, or the other way around? And the hint is in the question, in the order in which it asks. So we have how many people were there. Per is a divide symbol, so that's going to be people per square kilometer. So people divided by square kilometer. So we're going to take our people number, which is 3.42 times 10 to the 6th power, and divide it by 2.52 times 10 to the 5th power. We're going to use our calculator here, divide our a values first. So 3.42 divided by 2.52. And I'm going to round this to 2 decimal places, nearest hundredth. So it comes out to 1.357. So I'm going to just call it 1.36 because it's an approximation. Both these numbers are approximations. So 1.36 times, it looks like a variable x. We'll get rid of that. We'll call that times 10, and then our procedure for dividing powers with like bases is to do the top exponent minus the bottom. So 10 to the 6 minus 5, and that will leave us with a power of 1. And since this decimal is in the right spot, I don't have to make any adjustment for it. So it'd be 1.36 times 10 to the first. And we don't really need this exponent of 1. We can leave that off. They did want us to leave the answer in scientific notation, but if we wanted to make sense of that, that would be times 10, 13.6 people per square kilometer. So every square kilometer, Oregon would have just under 14 people living in it.